Hey everybody, today we're going to talk about relations and functions. Okay, so first we're going to talk about ordered pairs. Okay, ordered pairs can be used to show inputs and outputs. So here we have an ordered pair 5, 3. The input is 5. That's the x coordinate. That's always your input. The y coordinate is always your output, and that's the 3. Okay, now how does this go with relations? Well, a relation is a correspondence between two sets. It pairs an input with an output, and it can be represented by an ordered pair. So anytime you see an ordered pair, that's going to be a relation. A relation is sometimes called a mapping. Okay, so here we have a set. We have our inputs over here, we have our outputs over here. 0 is mapped to 0, 1 is mapped to 2, 2 is mapped to 4. Okay, so we have these ordered pairs here, 0, 0, 1, 2, and 2, 4. The equation that maps, or the mapping, is what takes your x to your y. So in this case, this would be y equals 2x. Okay, 2 times 0 is 0, 1 times 2 is 2, 2 times 2 is 4. Okay, now down here, we have another mapping. Okay, so the mapping is y equals 3x, and we've got our inputs and our outputs here. And so you're tasked with writing down the ordered pairs. So the ordered pairs would be 1 is mapped to 3, because 1 times 3 is 3. So I get the ordered pair 1, 3. Then I'm going to get 2, 6. Then I'm going to get 3, 9. Then I'm going to get 4, 12. Okay, there's my answers, my inputs and my outputs and my mapping. Okay, all these go just like this. Pretty simple. Okay, now a relation that pairs each input with exactly one output is called a function. And we all know that Mr. Lippy puts the fun in functions. Okay, so the question is here, is this relation a function? Well, negative 9 is mapped to 0. This x has exactly one y. 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 So this would be a function. So we would say, yes, this is a function. Okay, is this relation a function? So negative 2 is mapped to 3, that's not a problem. Negative 1 is mapped to 4, also not a problem. Oh, 0 is mapped to both 5 and 6. That's a problem. Now, this is not a problem that 0 and 1 are both mapped to 6. That's fine, because each x would have one y. But this one is a problem right here, because this x has two y's. This is not a function. It's a relation, but it's not a function. Now, the easiest way to tell if something is a function is to graph it and look at the graph, because there's something called a vertical line test. Okay? So, if I have a graph and I have a function, or I have a relation that looks like, okay, any line. Okay, here's my line. What the vertical line test says is, if I can take a line, a vertical line, and I can take that line and I can draw it through the graph anywhere I want to, and it only crosses the graph one time, it's a function. Okay, so this would be a function because no matter where I put this, it only crosses that red line once. Now, every single line is a function unless it's a vertical line, okay? A vertical line is not a function, because a vertical line would look like this, and then if I took this line and tried to do the vertical line test, well, right there, we have a problem. It passes through a whole bunch of different points. So this is not a function. All the rest of the lines are. Okay? Now, if I had, oops, that was supposed to be, say I had this, okay, and I did a vertical line, okay, does this pass the vertical line test? Well, it only crosses this thing, which is called a parabola. It only crosses it one time for each vertical line, so that is also a function. Now, if I have something that looks like this, okay, and now I have a vertical line, that's a problem because it crosses the graph at two different places. That is not a function. I find this the easiest way to tell if something's a function. Okay, so if I was to look at this, I could graph those points. Okay, so -2, 3. It wouldn't take me a whole long time to do this. That's not your best way to do it with points, but -1, 4 would be like right here. Okay, and then let's see, 5, 6, 7. So 0 would go to 5 and 6. So there's 5 and 6. And then 1 would go to 6, and 2 would go to 7. So I would have these points. Now, if I draw a vertical line here, I'm good here. Whoops. Let's get rid of that. I'm good here. I'm good here. Oh, I got a problem here. It passes through the graph in two different places. Once right here and once right here. That's not a function. Okay? So that's a visual way that you can do it. You know, every x, that's what you got to remember. Every x has to have exactly one y, and that makes it a function. Okay, so consider the mapping diagrams below. Are the relations functions? Describe the mapping between the sets. So this is super easy. Anytime you have, this is 1 to 1. Anytime you have one thing here to one thing over there, that thing's going to be a function. So this one's a function. Okay, I was going to have you do these on your own, but I forgot to have you pause it. So look at this one. Okay, there's a couple more here. So I'll have you do these two. Go ahead and pause the video and tell me, are these things functions or are they not functions? Okay, this one here, 1 goes to 1 and -1. That right there says that this is not a function. Okay, it doesn't matter what the rest is. Now this one is also messed up, but this one alone would be enough to trigger the whole thing to be not a function. Now this one is a function because every x has exactly one y. 1 has 1, -1 has 1, 2 has 4, -2 has 4. So this one's a function. And if you were to quickly graph those things, you can see okay, that 1 goes to 1, and -1 goes to 1, and 2 goes to 4, and -2 goes to 4. That's going to pass the vertical line test right there. Okay, but if I did this other one, and I graph these, so 1 to 1, 1 to -1, 4 to 2, 4 to -2. This is not going to pass a vertical line test here or there. Okay, it's just not going to work. All right. So, pretty simple lesson here. You're going to do 1 through 21 odd. I will see you in class. Have a great evening.